Hello, my name is Muhammad Aiman Hanif bin Muhammad Zakaria. I am the group leader of Group 3. The introduction of hydraulic engineering is a part of civil engineering is concerned with the flow and conveyance of fluid, principally water and sewage. One feature of the system is the use of gravity as the motivating force to cause the movement of the fluid. This area of civil engineering is immediately related to design of bridges, dams and channels, and both symmetry. The root drainage design has been one of the most important aspects in all countries to minimize the flood disaster. Our project is carried out to determine the type of suitable drain along the proposed channels 25 to 250 along 600-meter roads in Kampung Sungai Yap, Pahang, and to design the size of drain system based on restoration method for 20 years ARI event. The information is taken based on JKR standard drawing for road, word and MASPA.
The study area which is Kampung Sungai Yap, Jerantuk, Pahang. Kelantan, Pahang and Terengganu had been pouring non-stop as the northeast monsoon has started on 20 December 2014. Due to this occasion, most rivers of these states has reached a dangerous level and roads in Pahang were closed. Thus, it is important to calculate flow rate of the rainfall first before design a drain. Jerantuk has been chosen as a project focus as where Kampung Sungai Yap rainfall station was located.
Assalamualaikum and hi, my name is Nazir Nazim bin Sharul Nizam. My metric number is CF200203. So now I will explain to you guys about methodology in our project. So there are several methods that we use. This is the first method to find the flow rate of design, that is QD. So the first step is we need to determine the sub-catchment by using the contour given. The second step is we need to determine the flow of the water by pick the highest contour. So next we need to calculate the sub-catchment area depends on its shapes, neither square, trapezium or other. So the step 4 is we need to calculate average runoff coefficient, that is C, and average rainfall, the rainfall intensity, that is I. So after that, by the information of runoff coefficient and average rainfall intensity, we can calculate the flow rate for the catchment divide by section, that is QS equals to CIA divided by 360. So next we can calculate the area catchment that received by each channel. For the next step is we can calculate flow rate for the catchment by each channel, that is QC equals to CIA divided by 360. And the next step is we can choose a suitable design for each type of drain, neither interceptor, bench or roadside drain. For the next step, we need to calculate flow rate of the design, that is QD. QD equals to 1 over n AR to the power of 2 over 3 multiply by SO to the power of 1 over 2. So from this formula, we can get the flow rate of design, that is QD. So the last step is we need to compare the QD with the QS and QC, where QD must be greater than QS and QC. So if the QD is greater than QS and QC, so then we can proceed to the design output. But if not, we need to choose other design of drain or increase the design dimension. So other method that we use is we use a rational method to calculate the Q to calculate the peak flow, that is Q. So first step is we need to select design of ARI. So the second step is we need to descriptive the sub catchment by divide the sub catchment into a segment. Step 3 is we estimate time of the concentration, that is TC, by using the overland formula. For the step 4, we need to determine average rainfall intensity, that is I. And the next one is we need to estimate runoff coefficients, that is C. After that, we need to calculate average runoff coefficient, that is C average. And the last step is we need to calculate we can calculate the peak flow rate, that is Q, for the subcatchment. So that is the method for rational method. Other than that, we also refer to several table, that is Manning roughness coefficient table. Other than that, we also refer to Horton roughness table and table of runoff coefficient. So I think that's all for methodology. Thank you.
Assalamualaikum and hi, my name is Muhammad Daniel bin Tuntuh Kennedy. My metric number is CF200194. In this video, I will explain about the data analysis for this study. Challenge 25 to challenge 250 were taken to be our group study area. For this study, we are using the Urban Stormwater Management Manual Malaysia 2nd edition, or MASMA, as the reference. Okay, for this project, the area that we are taken as a study area is divided into 4 sections, which is area 1, area 2, area 3, and area 4. Area because to make sure the calculation process among the group members to become more efficient and to find the effective way to solve the problem as well as design the drain in the study area. The data that we collected are shown in the form of table. So from the table, area 1 and area 3 are categorized as the left side of the road on the west side, and area 2 and 4 are categorized as a right side of the road on the east side. And for each of these areas are divided into 2 components, which is road and highway, and open spaces, which is grass cover. The runoff coefficient is selected according to the condition of the study area, according to the table 2.5 in MASMA. So according to the table 2.5, the value of runoff coefficient for 20 years for road and highway will be 0.95, and for open spaces, grass cover will be 0.5. So for this study, we refer table 2.2 in MASMA for pave and average grass for Horton roughness value, which is for paved land surface we use 0.0915, and for average grass we use 0.045. We also refer JKR specification for the design of the drain in this study. So for most drain in this study, we use roadside drain type 2, which is cast in situ concrete drain. So the perimeter and weighted perimeter, so the area and the weighted perimeter of the drain are calculated as shown on the table. Then we calculated the travel time in the channel by referring table 2.3 in the MASMA for line drain section, which is 0.018 for rough finish.
Hi, my name is Nur Shazana binti Mazlan. My metric number CF2110396. And now I will talking about discussion and conclusion. So for the first discussion, the area at the location of Sungai Ya, Jerantut, is very flood since the annual rainfall intensity in 20 years in around 70 mm per hour if the storm duration is around 100 minutes. So in the project, we are able to apply MASMA second edition knowledge to perform our calculation for use in designing. So we had to determine and label applicative type often along the purpose road for CH0 to CH600, and we are successfully analysis and sketch the flow direction in the drain along the purpose start from CH25 until CH250 long road. So next, we discuss about queue of discharge. So for the left side from CH25 until CH250, we get 5.523 m power of 3 per second, while for the right side it is 5.156 meter power of 3 per second. Next, we find for Q peak flow. For flow, the left side from CH25 until CH250, we get the value is 0.531 meter power of 3 per second, while for the right side is 0.542 meter power of 3 per second. So next, for our conclusion, the drainage system is one of the most basic part of resident area. This is the need to maintain the drainage flow properly so that the surrounding environment is always a healthy and clean condition. If drainage is not handled properly, it may spread bacteria and many other harmful things that can affect the human body and nearby building. In choosing the design and type of drainage to be used in road design is also important, as all construction factors are very important. So, we conclude that our design is suitable and related with the data and calculation. Maybe some mistake will be able in calculation because it's doing manual also in Excel, Microsoft. So the drain design is good for ARI 20 years to handle flood scene based on MASMA calculation that we prove it in the report. That's all. Thank you.